All right, this is chapter 4.6a, the polynomial inequalities. So let's get started with number 20. So number 20, you want to make sure the first thing you see is that one side is equal to 0. Okay, that's good. And then the other side is in the factor form. Okay, that's good too. So what you need to do is go ahead and set each binomial equals to 0 and then solve for x. So you're going to see that x is equal to 5 and then x is going to equal to 2. Okay, so these two values are going to be plotted onto the number line. Okay, and then look at the inequality symbol is greater than. There's no or equal to. So what's going to happen here is that you're going to put in open circles for both of them. Okay, now I'm going to be doing some tests. So this is the testing part. You're going to test out this interval. Okay, so you can just put in any numbers. So I'm going to put x equals to 0 and test it out. What's going to happen here is that when you plug in 0 into x and see if this is greater than 0. And if you do your math, it's not greater than 0. So it's going to be false. If it's false, I'm going to say that, nope, that's not going to be part of our solutions. If you putting between 2 and 5, so let's just say x equals to 3, and then plug 3 into x and see if that's greater than 0. And then nope, it's going to be false. Okay, you gotta have to do your math over here. Lastly, you have to try anything above 5. Okay, so I'm gonna try x equals to 6. If you plug in 6 into x, you guys are gonna find out that yes, this is greater than 0. Okay, so for x equals to 6 is true. So that's gonna be your solution. Okay, anything greater than 5. So this is how you put it. You're going to put x, this notation, and put x is greater than 5. All right, so this is number 24. What you need to do first is go ahead and add 15x squared on both sides. Okay, so this is going to give you 3x cubed plus 15x squared is less than 0. So look at this. I got one side that's 0. Next thing you want to do is make sure that this side is in the factor form. So I'm going to factor out the 3x squared out. So that gives you x plus 5 less than 0. Okay, let's go ahead and set each equals to 0. Each factor equals to 0. So x is going to equal to 0 and x is going to equal to negative 5. Okay, so the 0 is what we're going to use and there's going to be a negative 5. And we're going to be starting to testing out the intervals. So I'm going to do the test right here. Okay, before I do the test, forget to tell you guys that the inequality symbol does not contain equal sign. So that means that you have to put open circles for both of them. Okay, so let's do the test. So I'm going to test out anything above 0. So I can just use x equals to 1. If you try x equals to 1, plug it in, and you're going to find out that nope, this is not true. So I'm going to put false. Next, I want to put something between negative 5 and 0. So I'm going to say, what if x equals to negative 1? Okay, do your math. You're going to see that it's false. Try this. So less than negative 5. So I'm going to put x equals to negative 6. And you do your math. You guys going to find out that yes, this is going to be true. Okay, so your solution is not going to be these two parts, and it's going to be anything less than negative 5. So when you write down your solution, you're going to do the interesting notation where it says x is less than negative 5. Okay. All right, so let's check out number 28. One side is equal to 0. That's good. But we need to make sure this side is in the factor form. Okay, so I'm going to go ahead and factor it. Factor out the x. So that's going to be x squared plus 2x minus 3 greater than 0. Let's go ahead and factor out the quadratic expression. So that's going to be x plus 3 times x minus 1. Okay, so let's go ahead and set each factor equal to 0 and find out what we need to mark on the number line. So you're going to find out that x is equal to 0, x is going to equal to negative 3, and x is equal to 1. Okay, so that's what I need to plot on the number line. So 0 is already there. And I'm going to put 1 over here. And I'm going to put negative 3 over here. Okay, so if you guys look at the inequality symbol, that's going to give you open circles. Okay, so open circle for all of them. Now let's do the test. Okay, so I'm going to use, for this part, I'm going to use x equals to positive 2. And if you guys do your math, this is true. Okay, so this is going to be part of your solutions. Okay, now if x is equal to 1/2 for this interval, you're going to find out it's not true, so false. So this part is not true. And then for this interval right here, I can just put x equals to negative 1, plug it into the original expression, and it's true. Okay, so I'm going to say that this part is true. And last one, you're going to pick anything less than negative 3. So I will say x equals to negative 4, and you're going to find out that no, this is false. Okay, so this part is not part of our solutions. The way you write the solution, go ahead and put that notation and put the inequalities there. So answer is going to be between negative 3, like this, and 0. So open circle means is less than and less than. And put x in between. Or this part, we're going to say that x is greater than 1. Close the bracket. Move on to the next question. 32. So you want to subtract 1 on both sides. Okay, make sure that one side equals to 0. So I have x cubed minus 1 is greater than 0. Okay, go ahead. We have to just set this equal to 0 because it's already a binomial, right? So I have x cubed minus 1 equals to 0. So x cubed equals to 1. Okay, so x is going to equal to 1. The only number we're going to put in is 1. Okay, inequality symbol is greater than, which means that I'm going to put open circle. Okay, so next thing I want to do is go ahead and doing the test. So that's there are only 2 intervals for you to test it out. So I can just go ahead and use x equals to 2 and see what happened. Plug it in. True. Okay. So this part of the solution, the interval is going to be your solution. That's good. And then if I try to test out a number from the anything less than 1, I can put 0 in there. So x equals to 0 and see how it goes. And you guys going to find out that this is false. Okay, so this is not going to be part of your solution. Your answer is going to be x greater than 1. All right, so peace out.